This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Hello guys, great to have you here once again.
So finally, hello everybody. My name is Szymon. I'm software engineer at QA team in BEC. I've joined BEC 3.5 years ago as a junior software engineer. And since then, I'm developing testing tools.
Hi, and I'm Bartosz Filipek, the architect within the QA team. It's my fault you had to wait for me for a second. Sorry. But today, with Szymon, we will take you on a journey with us, actually, to the Jurassic Park. So my first question would be, have you seen, or maybe differently, haven't you seen the Jurassic Park movie?
Yes.
Haven't you?
But I think
okay, so
most
you
of them
can
saw
hide
them.
your eyes, close your ears, unless it will be another spoiler right after the spoiler from Łukasz. We will have in this presentation some parts of the Jurassic Park movie. Sorry.
Yeah, so this is the time to leave if you still want to watch it. But if not, then let's start by answering the question that probably you have in your mind right now. Hello? My mic is not working. Oh, now it is working. Great. So probably you are wondering right now why we are talking about Jurassic Park, since this is a QA conference, right? So actually, Jurassic Park was a quite cool project. And they've built beautiful advanced buildings, the infrastructure for transportation across the whole island. They've also built IT infrastructure to control all the cool technology that they had in the park. They had very advanced laboratory that was growing brand new dinosaurs. And finally, they had the system of electrical fence that was keeping all the dinosaurs, but keeping people safe from the dinosaurs. So it was very advanced. And actually, if you think about it, this project was not much different from the project that we are working on. So maybe it will be cool to do a little case study on the Jurassic Park, but with our QA perspective. Because this title of this presentation is QA Jurassic Park, but actually the most important topic of this presentation is you guys, QAs. Why? Because QAs very often, when joining organizations, are like rock stars. Rock stars among many scientists. And by this, we mean developers, of course. So they are like rock stars, individuals. But not everybody in the organization is probably perceiving you that way. Not everybody is probably sharing your attention to the quality, market standard tools, best practices, and so on, right?
Yeah, and among those, as usual, there are people that are pretending, that are caring about the quality, right? There will be people like those from the processes that will send you the survey to check how your quality looks like, how the things are going. But actually, they are quite artificial in this way, like the lawyer within the movie. Actually, he was caring about the quality. He was deeply concerned because he was sent by the stakeholders, by the investors, actually, right? So he was, at the end, caring only about the money. When he sued for the first time, Dino, then he was totally convinced that it's fine, despite the fact that he was sent because one guy was eaten a couple of weeks ago by the Dino. Well, happens. But going actually further on, there was also the business, right? The guys that were counting about the big money, quick return from the investment, and like at the beginning in the movie, they had really nice computer that was able to scan the ground for the bones and actually analyzing where to dig to do it as fast as it's possible and have surprise return of the investment.
Yeah, so money always wins. And this is something that you probably have the first occasion to learn when you join your first job, your first company. Maybe you remember your first job. Maybe you were excited back then to see how the big boys are handling their big projects, how they are using the best practices, and maybe you was hoping to see the best standards on the market, because since now we were just learning or something. Do you remember your reaction when you came and looked around? Maybe this reaction was similar to this one, because instead of seeing beautiful tools, beautiful standards, instead you saw giant, dangerous, very old dinosaurs. But yeah, and it was in cases of many of us. It happened to many of us. But at some point, you start to accept it, the situation, and you chill out. But you're hoping for the better still, right? This should be solved soon. Maybe it will be better soon. But you wait, start to look around, and you see that instead they are growing more and more new dinosaurs. So this problem is just growing.
Yeah. And among those dinosaurs, among the people that were surrounding, there was, even in the movie, the exotical guy, the alarmist from Kenya. That was the game warden, actually. And he was caring about the quality. So he was a perfect example of the quality assurance engineer within the organization, actually driven by this CEO. But through all the time, he was pointing that the fence is not enough, the electric fence. The raptors that were actually the most dangerous can still escape from the cage, and it's not fully safe. And imagine the situation that at some point, actually, the CEO even brought his grandkids. And they've done the test on the production. Why not? And that didn't went well, actually. The back end was looking terrible. Actually, those guys sitting in the room were noting another bug after another. At the moment, actually, that the cars that were actually available previously on the slide from Szymon, they got broke in the Jurassic Park. And they've noted that it's 151 glitch noted today. Why not?
Yeah, huge amount of glitches if you want to test on production on your kids, but not me to judge. And since we are getting to the technical aspects, do you want to see the technical team that was leading the whole initiative? Okay, so let's look at the team. Maybe you are right now imagining a bunch of specialists, you know, the best ones, writing the code and making sure everything is fine. So this was the team. One guy writing 2 million lines of code. I wonder who was doing the code review for him. Probably himself, right? Yeah, and based on what he said, it's clear that he misunderstood totally the concept of automation, because he was bragging that he can do it on his own, and he was proud of it. Right now, in the modern world, in IT projects, we call such situations dependency bottlenecks, because you cannot afford having the whole project depend on just one guy, right? What do you think? He remembered to put and write some tests? No, he didn't. And what was the result? You probably can guess the result from the face of Samuel L. Jackson right here. because at some point this whole park broke down, and they weren't prepared for it. They didn't have failover testing, but they had one brilliant idea how to solve it. And probably this is the idea that you always have in mind when something breaks down and you don't know what to do. Let's turn it off and on again. But they weren't even sure if that will work because they never done it. So there were literally no test at all. And at the end, to sum up this whole situation, they had beautiful technology. They had huge budget. The whole project looked amazing. It was very attractive, and they had dinosaurs. So it's a great product. But it all failed, and they totally lost control over it.
At this point, actually, we had a small reflection together that this architecture design looks very similar to the well-known nowadays, actually DDD, dinosaur-driven development. And we have noticed that we have some connections between the movie in our life, actually, in our situation within the BC a bit. And we were digging like those archaeologists, right, a bit around. And we have noticed that we have something that could be called the Cobble Park, with the heart of the mainframe inside and lot of Cobble programs that are actually our dinosaurs. But let's be honest with ourselves. It started already 60 years ago.
Yeah, at that time, they chose the best available technology, mainframe, Cobble, but they were lacking some tools because on the market, they weren't available at all. So what they decided to do? They decided to go with the customization path. Yeah, and it all started back then, but you probably know that when you build one customization, then it's most likely that the new customization will be introduced soon on the top of it. And that's actually what happened. And amount of customization is just growing. And the more customizations you have in your project, the farther you go from the market standard tools way. And right now, I would like to do a little survey and ask you guys, how many of you notice some customizations in your company? I wonder how many people work with customizations on a daily basis. Okay, I see some hands. Oh, more and more. Yeah, I think nearly half of people here. So that's a common problem. So right now, we would like to share with you the dinosaurs that we noticed when we joined BC. So let me talk a little bit about that. So first of all, let's start from the test environment. And a huge portion of this test environment is DB. So let's picture the database as those tables here. And of course, we have the dinosaurs. So Cobble programs, very big ones, old ones. And they are talking to each other. And they have a dependency to each other. And those programs are developed in different teams. But this is normal. So for example, here, team 6 has a dependency to team 3. So what will happen when team 3 will update the program? It can break the whole process from team 6, right? And imagine that at each change, the program was uploaded to the test environment automatically. So team 6 all the time had a broken environment and so on. Of course, those programs are talking to the database. And of course, like in this situation, they are sharing one table between each other. So team 1 and team 2 has a problem in this situation. So going back to the team 6, maybe they have some integration tests. Yeah, they have. Manual integration tests, you cannot automate them. I mean, it was very hard to do. But you cannot rely on the results of this integration test because if anything changes in the test environment, it will affect the result. So we faced a lot of issues regarding the test environment. And oh, new dinosaur. To sum up all the problems, issues we faced, first of all, there was no stable test environment. We didn't have a unit testing tool for COBOL, so it was awful. And there was lack of documentation. No testing process was defined. And finally, automated integration test couldn't be automated at all. So how we approached it, you may ask. So we started from observing COBOL developers and see how they are trying to test, because they were testing manually. And we noticed that they were using debug tool on the mainframe for debugging COBOL to stop at a certain point in the program logic, list values, maybe sometimes change them if they wanted to mock them. And this is how they verified if the program was working fine. And this was all manual. So we decided to go deeper into documentation and to see if we can use it as a heart, the engine of our unit testing tool. So we decided to go this way. And we confirmed that this testing tool has, and this is how it looks like, it has enough features to serve as unit testing tool. And this is how BCAT, COBOL unit testing tool, was born. And we take care enough to make it standard way. So it was working fine for all the mainframes. It can support all the mainframes in the world. And how it is working in the details. Let's quickly go through the process how it's working. We have a developer on the left, and developer needs to create a test case. Test case is written in Java. So it can be run from local machine, CI/CD pipeline. The engine is JUnit, so that's market standard tool. And based on the test case written in Java, we are producing test scripts. And those test scripts are then sent to the mainframe to be ready to start the execution of the program itself. We start execution on the mainframe, but in the debug mode. And the debugger will perform all the instructions from debug script. So the developer is writing Java test cases, which can be nicely versioned and so on. But at the end, everything is translated to work on the mainframe. And the result is a log, which is then analyzed, and you can produce all the reports, beautiful reports. You can then plug it to the other cool tools. To sum up the features of the BCAT from the tester perspective, first one, this one I didn't mention yet, is graph generation. And this feature is really useful, and I would like to have something in Java like that, because this one is analyzing the program execution in the runtime and trying to observe what the program is doing. And based on that, it's building this graph that explains where the program logic is going through the COBOL program. And this is especially useful when you have very long COBOL programs. And thanks to that, you can see what kind of parts of logic are used for specific business case. Second one, also the one I would like to have in Java, recording of mocking values. And this is something that is also working automatically. It is detecting points in logic which is a good candidate for mocks. It is recording it in the form of very long log. And then mocking is fairly easy because it's a one-liner. So you can reproduce the mocks for specific runtime case. And at the end, you might have guessed it, assertions. You can perform assertions for all the different stuff that you need to assert in COBOL program.
But do you think that it's enough? Are those unit tests enough? Okay. We had a different opinion. So actually, to come up with something that will be more closer to the human being, actually, we've implemented the service that is it's the microservice as operating over the REST API and gives a possibility to interact the end user with the COBOL programs through the REST API. We named it Test Data Factory because at the beginning, actually, it was used not only for the tests of those COBOL programs, but as Szymon mentioned already, we had already problems with test environment and data. So we actually needed some artificial stuff to be present within the database, even to operate over yours data. And to do so, we had to actually take the standard JSON. Let's have someone Bisosaurus. And this Bisosaurus should appear actually within the database somehow, right? So we had to translate that into the bytes. Normally people would name it because it's going in both directions, serialization and deserialization, right? But we need something else. We needed also the reference directly from the mainframe. It's called the copybook. It gives us a possibility to chop actually the information from this beautiful JSON into this. I'm not gonna lie, I don't remember if it's exactly the same. But if you want, you can actually copy, make a photo, and check by yourself. And actually, that gave us the option to operate over, to check the status not only of your COBOL programs, right? Because they were in the heart, in the source of the system, but also to generate data. And we approached it in quite simple way. There was a JSON actually sent to the Java application, the microservice that I mentioned already, with the Spring and the OpenShift. And those customizations hit us also. We had to set the communication to the mainframe, but it wasn't the standard one. So we had to, at least at the moment, adapt to the situation that we had. And thanks to the Bitbucket, actually, they have REST API. So at least for the reference copybooks, we were able to reuse the REST API. That is standard and well known, actually. At this point, someone from development team, tester, developer, whoever, is able actually to operate over the CI/CD with, for example, Jenkins, or from your local machine. Hit the service that is present outside through the JSON and send those bytes out to our beloved mainframe. After execution, we receive the whole info back as the REST response.
And to sum up and to share our reflection after this whole process, after those few years that we spent analyzing this situation and how to solve the issue for the whole company, we would like to share our reflection on it. And not from the point of authority, but as people who develop stuff and are QAs. And actually, the movie has a very interesting message for QAs. Because this Jurassic Park, you remember, it was beautiful. It was beautiful. And the product was amazing, and everybody fell for it. So, but there was one guy, the game warden, who had different opinion, but his voice wasn't heard. And all the people there had just illusion of control over the park. So they were very excited, but this was only an illusion that this project has real value. So you as a QAs need to look at the fundamentals, and you need to judge if this if your project has this value.
Going actually further on those conclusions, what we've learned from the situation that we actually received, is that it's important to educate people, especially those that were developing some stuff 60 years ago. And believe me, we had such within the company. We have still, probably. We need to adapt a bit, right? Because it's not easy to actually implement something in very customized world, right? We were trying to back on track with the standards. It's still ongoing process. We've not ended the journey yet, right? We are just trying to push the things back as they should be. Then I know that QAs are very often compared to detectives, but in our case, and I can bet in some of your cases, the detective hat is not enough. You have to dig a bit. So wearing this archaeologist hat might be the thing for you also, right? Beside of that, remember about the technical depth. Those dinosaurs were not only built by the COBOL developers, actually, right? Because there were different other developers. They could do something. They could act. The same goes for the QAs. They could act a bit. Follow best practices and standards. It's easier to communicate through the REST API with some JWT token instead of some customized Kix IP. Probably some of you know something like that? No one? No? Okay. Read documentation and understand it. It was very crucial, especially for the mainframe part that Szymon was also explaining to you, because we couldn't rely only on the documentation that we had. There was way too little of it. So we had to actually dig in to the IBM part to check how the things are going, how it works, and how, in a standard way, IBM is doing some stuff, like with the debug script. And to summarize, actually, what we've wanted to tell you at the end and bullet point those things, expect unexpected, because I know that when you're coming to the new organization, you expect to have nice stuff, but you are ending like this guy that was on the GIF, actually. It's not the best place. And break the rules. Don't act like the QA that was present, this one from Kenya, because I didn't want to spoil it also at the beginning. He was a little bit too silent because he was even eaten by the raptors. With those conclusions, we would like to thank you.
Thank you.
Thank you very much. Thank you, Bartosz. Thank you, Szymon. Thanks so much for your presentation. Now, are there any archaeologists in the audience who want to dig deeper and ask some questions? Do we have any questions in the audience? Any raised hand in not only the ones taking photos? No, I don't think so. So everything's clear. Oh. Okay, maybe I will join you with the microphone, okay, so that everyone can hear you, but there's something about the first base.
Does it take?
Regarding the development, it took, I think, a few years.
Already 2 years,
Yeah.
I think.
Yeah.
But I'm not gonna lie, for the first year, because I'm shorter than Szymon within the company, for the first year, probably we were checking how the things are working.
Yeah, just
and how we can
stuff.
actually do the stuff. We had long warm-up.
Yeah, but during this journey, we had also very interesting moments. And maybe I can share just one. We had a meeting in Austria because there's a not QA conference, but IBM conference there, and just people that are devoted to modernization of the mainframe meet together and they talk to IBM people, sharing their experience with the companies, and this is how they gather the information, what to develop in in the IBM tools. And actually, we had, as a part of this process, we had the occasion to go to Austria to meet those guys. And it was very interesting a meeting because just 30 people from around the world. And I had the opportunity to talk to the initial developer of the debug tool. So it was very cool to show him the bugs that I found in the debugger itself, and to find out that nobody in the world were using stuff like we did. So it was a very interesting journey because we could have a sense of accomplishing something that is not available on the market, but it's still written in a standard approach. So it took 3 years, I would say, and also credits to all the people that also were working on this idea before us. But a few years sometimes you need to devote to work on an issue. But now it's very quickly for us to develop new features because we came a very long way regarding the technicals. This is great question, and I think
let's say
but
5.
Let's say 5. Yeah, 5. Yeah. But when you are counting only the developing the tool itself, I think 3. So it's not enough, but still you can achieve something.
For those who didn't hear, the question was about the amount of people working on that. Okay, guys, thank you so much. Do we have any other questions in the audience? I don't think so. So to embrace the sense of accomplishment, we will be now presenting the QA Community Awards for our speakers. So
Thank you.
round of applause.
Thank you.